museum records demonstrating the presence of a species at some locations in the past, and contemporary surveys showing that the species is not now present in those areas. We have prima facie evidence of range contractions. We have to bear in mind the usual caveats, of course, provenance accuracy, contemporary sampling effort and seasonality, none of which apply with any severity to the species I'll be talking about today. Brachidontes rostratus, the purple mussel. It's the dominant organism at the intermittent tidal range and many regions of its distribution, for instance here at Bicheno in eastern Tasmania and on the Otway coast in Victoria. This is the distribution map as shown in ALA records with some indications of geographic names I'll be speaking about today. Its range extends from central South Australia through to southern New South Wales, where its northern limit marks the traditionally recognised boundary of the Peronian and Maugean biogeographical provinces. This is one of the two major biogeographical boundaries in southeast Australian waters, and Brachidontes has been used as the principal indicator of that range limit. Here, in the context of this seminar, I should give a nod to our colleagues in Herbaria. The most recent confirmation of the magnitude of the species turnover at this biogeographical boundary has been provided from the algal records in the Australian Virtual Herbarium. In New South Wales, the species rostratus probably never attained the abundance and ecological importance that it has in other states where it's a habitat engineer. But as I mentioned, it is an indicator of that biogeographical boundary, and it does persist at some low numbers in the state at the moment. It doesn't occur in the same numbers as it did in the 1950s, where it was recorded at, say, Churros Heads as forming large clumps of mussels, but it is still there. Apparently, however, its range and abundance are being reduced. The Australian Museum survey in 2009 of southern New South Wales mussels revealed an apparent latitudinal contraction in that state, contraction to the south. This map shows the Australian Museum records in black circles with dates of collection. For clarity, I've removed the areas of the sample sites from southern New South Wales and Victoria. The red circles indicate those places where the species has been found in recent collections or in 2009, and the empty circles indicate those spaces where we could not find the mussels in our 2009 surveys. With some effort, I imagine we could move the current northern distribution up towards Narooma, but it's apparent from this record that we have a significant latitudinal contraction to the south. That's actually of about 1 degree in terms of latitude over a period of 60 years. If this is typical of the effects on cool temperate species, we may be looking at, and it continues for the next 50 years, we may possibly be looking at the loss of an entire Maugean fauna from the state of New South Wales. It's tempting to ascribe the range reduction to the increase in seawater temperatures in the Tasman Sea hotspot, where the Peronian-Maugean transition is sited. Over the last 60 years, there's been an average sea surface temperature increase of more than 2 degrees, about 3 times the global average. They could be direct effects of the increase in temperature, or there might be indirect effects such as the southern movement of potential predators of the species. We should always remember that correlation is not causation, and there are many other possible scenarios that we might envisage, such as oceanographic currents and the effects on countercurrents. But we should also bear in mind the precautionary principle, which in this instance suggests that we do bear or give close consideration to the implications of the range reduction of rostratus being due to environmental changes. What can be done? This raises the troubling question of what should be done, and that's by no means an easy question to answer, and it requires hard decisions about human rights and responsibilities in intervening in natural systems. This is particularly pointed in this case because there are some management options, such as translocations or artificial connectivities across the 90-mile beach, that could be done. In most situations where you've got a range reduction, there's little that we can actually envisage doing, but here we do have some possibilities. The pros and cons of these actions are beyond the scope of this talk, so I'll leave them possibly for later discussion. But there are a couple of actions relating to how we manage collections that I would like to highlight in conclusion. The first is that we should continue to monitor indicator species to give us a reasonable idea of the magnitude of potential climate change effects. The second is that we can look in more detail at less conspicuous taxa to get an idea of the generality of the potential effects of climate change in causing range reductions. One aspect of this is that we may thereby identify indicator species, leading indicator species. Brachidontes is a fairly hardy species living in a pretty tough environment and managing to cling on in little crevices here and there at the northern range of its, at the northern limit of its range. And this ability to hold on may be masking the pace of environmental change, masking the deleterious effects, and also masking those slight glimmers of positive effects that we might hopefully see in the future. Thank you. I'd gratefully acknowledge Peter Middlefart and the funders of this research.